So the next topic of discussion are quadratic functions. Quadratic functions. So we've already seen linear functions, so those are all the form mx plus b, so we had f of x equals mx plus b. Now we're going to talk about quadratic functions. So linear functions, the largest power on x was 1. Quadratic functions, the largest power is going to be 2. So the way their graphs look are parabolas. So we can have one that's facing up, or we can have one that's facing down. So a quadratic function is always going to have a graph of a parabola like so. We should define it. A quadratic function is a function of the form f of x is ax squared plus bx plus c, where a is not 0. So any function of the form a number x times x squared plus a number times x plus c, where a is not equal to 0, is going to be quadratic. Now it is possible that b and or c is 0, so you might just have one term, but anytime the largest power on x is 2, that's going to be a quadratic function. So that's the definition of that. We also are going to do the definition of a discriminant. Spell it right here. Discriminant. So the discriminant of a quadratic function is d, and it is b squared minus 4ac. So anytime you have a quadratic function, you can find its discriminant, which is b squared minus 4ac, and the discriminant can actually tell you a lot. So there are 3 cases for the discriminant. Number 1, the discriminant is 0. If the discriminant is 0, then f of x has exactly one root. So remember what a root was. A root is an x value, so that the function is equal to 0. So if the discriminant is equal to 0, then f of x has exactly one root. In that case, the graph is either going to be a parabola that touches the x-axis going up, or it'll be a parabola that touches the x-axis and kind of is facing downwards. So if the discriminant's 0, that tells you you have exactly one root. Now let's say that your discriminant is negative, so it's less than 0. In this case, then f of x has no real roots. So I should have specified we're talking about real numbers here. So f of x has no real roots. In that case, what is the graph going to look like? It'll be a parabola either lying entirely above the x-axis or lying entirely below the x-axis. So if your discriminant is less than 0, then we have no real roots, so you'll have either above the x-axis or below. And then lastly, what happens if you have a positive discriminant? Then f of x has 2 real roots. So if you remember about roots, a root is where the graph crosses the x-axis. So you could see when we had one root, it touched the x-axis at one place. No real roots, it didn't touch the x-axis. Now we're going to have 2, so it can either look like this, or something like maybe this. So anywhere that you have the curve crossing the x-axis twice. So discriminant tells you how many roots we have and kind of the overall shape of the graph. To find the roots, you're going to set the entire function equal to 0. So if you set the function equal to 0, there are a couple things you can do. You can either factor, you can complete the square, which is a later video, or you can use the quadratic formula. So to find roots, you set f of x, which is ax squared plus bx plus c equal to 0. If you solve this for x, we'll get that x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So you can see where the discriminant is in terms of our root. It's the part underneath the radical. So that's why the discriminant tells us how many roots, because if this is equal to 0, well, adding and subtracting 0 is the same thing, so we're only going to have one root. If it's negative, then this is undefined in the real number system, so we're not going to have any roots. If this is positive, then we're going to have the square root is another positive number, so plus and minus of that will give two distinct roots. So anytime you need to find roots, you can factor or the quadratic formula. So the quadratic formula is how you solve for x once the quadratic is set equal to 0. Now it's really important that the quadratic is set equal to 0, otherwise you can't use this formula. So for example, let's find the roots of f of x. F of x here is 2x squared minus 4x minus 6. So you could factor, that's one way to do this, or we can use the quadratic formula. So that tells us that x is negative b. Here my b is negative 4, so I take the opposite of that, so 4. Plus or minus the square root of b squared, so negative 4 squared is 16. Minus 4 times a here is 2, c here is negative 6, all over 2 times a, which is 4. Now we're going to need to simplify this a little bit. So I get 4 plus or minus the square root. 4 times, well, let's do, first of all, the negatives are going to cancel, so let's go ahead and do that. Then I have 2 times 6 is 12. 12 times 4 is 48. So I'll have 16 plus 48 all over 4. And what happens when I add these two? So 16 plus 48 is going to be 64. So 64 is under my radical. Square root of 64 is 8, so I get 4 plus or minus 8 over 4. So what are my two roots? The first root is going to be 4 plus 8 over 4, which is 12 over 4, which is 3. My second root is going to be 4 minus 8 over 4, which is negative 4 over 4, which is negative 1. So what are the roots? The roots are x is equal to negative 1 or 3. Those are the two x values that give me my function is 0, which we found by using the quadratic formula. Let's try another one. Let's find the roots of f of x is 3x squared minus 6x plus 3. So again, you could factor this if you wanted to, or you can use the quadratic formulas, which is what we're going to do. So x is the opposite of b, so here b is negative 6, so the opposite of that is positive 6. Plus or minus the square root of b squared, so that's going to be 36. Minus 4 times a, here's 3, times c, also 3. All over 2a, which is 2 times 3 is 6. So 4 times 3 is 12. 12 times 3 is 36, so I get the square root of 0. So it's important here that our discriminant is 0, because remember when the discriminant is 0, I'm going to have one root, because the square root of 0 is just 0. So this is really just 6 over 6, because adding or subtracting 0 doesn't do anything, so just 1. So I have one root is x equals 1, and that's the only root that I could find. One more. Let's find the roots, if there are any, of f of x is negative x squared minus x minus 1. So to find the roots, I'm going to set this equal to 0. I could factor it. I could use the quadratic formula. Let's go ahead and do that. So the opposite of b here is negative 1. Opposite of that will be positive 1. Plus or minus the square root of b squared. That's negative 1 squared is 1. Minus 4 times a is negative 1. C is negative 1. All over negative 2, because that's 2a. So what do I get underneath the radical? Well, I have 4 times negative 1 is negative 4, times negative 1 is 4, so 1 minus 4 is negative 3. The discriminant here is -3, that's negative. Well, when I have a negative discriminant, that means no roots. Also because what is the square root of -3? That's undefined. So there are no roots here. Why do we care about these roots so much? Because if we have roots, we can factor our quadratic. So we can factor f of x. So let's say your two roots, or you could just have one. So let's say the roots are r1 and r2. Then f of x, which was ax squared plus bx plus c, I can rewrite this. So once you know what the two roots are, we said they're r1 and r2, this is going to be equal to a, so a comes out front, x minus r1 times x minus r2. How does that help us? Go back to our example that we just did, example 1. We found out that f of x, which in our example was 2x squared minus 4x minus 6, has roots. X was equal to 3 and -1. So that tells us that 2x squared minus 4x minus 6, I could rewrite that as 2, because that's my a term, x minus 3, and then x minus a -1 turns into x plus 1. So I could factor my polynomial. So again, once you know the roots, and you know what your a term is, bring out a, and then write down x minus your roots. So let's do the same thing for my second one. So my second example, I had f of x was 3x squared minus 6x plus 3. The roots here are x equals 1. We only had one root. So f of x was 3x squared minus 6x plus 3. I could rewrite this as 3 times x minus 1, x minus 1. So the reason I write this twice is because there's only one root, which is 3 times x minus 1 squared. Again, this squared term here tells you this is a double root, so that is the only root. So that's how you factor it. Our third example didn't have any roots, so we can't factor that any. Now what this does for the graph is the roots tell you where to intersect the x-axis. Intersect the x-axis. A tells you whether the parabola goes up or down. So once you know the roots, you know where it intersects the x-axis. If a is positive, it's going to be an upward parabola. If it's negative, it's going to be a downward facing parabola. So go back up to our example 1. Example 1 was 3x squared minus 6x plus 3. Let's try to sketch the graph of this. The two roots there, if you remember, the two roots were 3 and -1. So here's -1, here's 3. I also know that a here is positive. That means it's going to be facing upwards parabola. So I could sketch my graph to be something like this. So once I find my two roots, that tells me where I intersect the x-axis. A here was positive, faces up. Let's do my second example. So example 2 was f of x was 3x squared minus 6x plus 3. Oh, got that backwards. Sorry. Go back to example 1. We'll start over. I accidentally messed that up. Example 1 was 2x squared minus 4x minus 6, which is f of x. That was the graph that we just drew. -1 to 3. Sorry, wrote down the wrong function. Example 2 was the 3x squared minus 6x plus 3. So in example 1, I just wrote down the wrong function to begin with. My roots were -1 and 3. Plotted those. 2 was positive, so it faces up. Let's do this one. What were my roots here? Well, I only had 1. I had a root at 1. 3 is positive, so it's facing upwards. So this is my function. And then lastly, let's look at my last function, which was negative x squared minus x minus 1. Now, this doesn't have any roots, which means that it's not going to intersect the x-axis at all. Do I know any points on this graph? Well, when x is 0, I get that my f of x is negative 1. So I'm going to have the point 0, negative 1 on the graph. So it looks like that. It's facing down. So there's my f of x. You can see it doesn't intersect the x-axis. So I have no roots. The second example had 1 root. First example had 2 roots, so I apologize for messing that up, but you can see how the 3 graphs are going to look. So that's how you're going to use the roots to sketch the graph.